Modernage MCQs Physics second year, unit number 16, Physics of Solids, part 5. The resistance of silver and mercury at 7 Kelvin respectively is Rs and Rm then. Option A, Rs is equal to 0. Option B, Rs less than Rm. Option C, Rs greater than Rm. Option D, Rs is equal to Rm. The key is Rs greater than Rm. Therefore, the correct option is C. Reason. The resistance of conductor depends upon the temperature. The fall in temperature decreases the resistance. The decrease in the resistance of mercury is faster than the silver with decrease in temperature. At 7 Kelvin, the resistance of silver is greater than mercury. Hence, Rs is greater than Rm. The magnetism in a magnetic material is mainly due to option A, motion of electrons in atoms, option B, motion of neutrons in nucleus, option C, vibration of atoms in material, option D, change in volume of material. The key is motion of electrons in atoms. Therefore, the correct option is A. Reason. The charge in motion has electric as well as magnetic fields. Therefore, magnetism in a material is due to the motion of charges. In option B, C, and D, there is no charge in motion. Therefore, the magnetism in a magnetic material is mainly due to spin and orbital motion of electrons. Hence, the magnetism is due to motion of electrons in atoms. An atom behaves like a tiny magnet in option A, non-magnetic material, option B, diamagnetic material, option C, paramagnetic material, option D, ferromagnetic material. The key is paramagnetic material. Therefore, the correct option is C. Reason. In paramagnetic materials, magnetic fields due to orbital and spin motion support each other. Therefore, an atom behaves like a tiny magnet. This property defines paramagnetic material. Hence, an atom behaves like a tiny magnet in paramagnetic material. A domain is a tiny magnet in option A, ferromagnetic material, option B, non-magnetic material, option C, diamagnetic material, option D, paramagnetic material. The key is ferromagnetic material. Therefore, the correct option is A. Reason. In paramagnetic materials, magnetic fields due to orbital and spin motion support each other. A domain is a tiny magnet in a ferromagnetic material containing 10 power 12 to 10 power 16 magnetic atoms. Hence, a domain is a tiny magnet in ferromagnetic material. The Curie temperature is temperature at which ferromagnetic material behaves like option A, ferromagnetic material, option B, non-magnetic material, option C, paramagnetic material, option D, diamagnetic material. The key is paramagnetic material. Therefore, the correct option is C. Reason. At Curie temperature, atoms in a domain lose their alignment and act independently like the atoms of paramagnetic material. Hence, at the Curie temperature, ferromagnetic material behaves like paramagnetic materials. The coils of step-up transformer are wound on laminated core of option A, copper, option B, iron, option C, silver, option D, gold. The key is iron. Therefore, the correct option is B. Reason. Iron is a ferromagnetic material. The laminated soft iron is used as a core to reduce eddy and hysteresis power losses. Therefore, coils of step-up or step-down transformers are wound on the laminated core of iron. Hence, the coils of transformer are wound on iron core. At zero coercive force, the area A of hysteresis loop is option A is equal to 0, option B, A greater than 0, option C, A less than 0, option D, A less than or equal to 0. The key is A is equal to 0. Therefore, the correct option is A. Reason: the area of a hysteresis loop depends on magnetic field H, coercive force, and magnetic flux density B. When H reduces to zero, B is not completely washed out from ferromagnetic material. Now B is equal to retentivity of the substance. Its value is along the magnetic flux density. Hence, at zero coercive force, the area A of hysteresis loop is zero. In a cycle of magnetization and demagnetization of a material, the hysteresis lagging of magnetic A option, flux density B behind the magnetic field H, B option, field H behind magnetic flux density B, C option, field H behind the current I, D option, field H behind the voltage V. The key is flux density B behind magnetic field H. Therefore, the correct option is A. Reason: lagging of magnetic flux density B behind magnetic field H. Magnetizing force: if a magnetic material is subjected to a cycle of magnetization is known as magnetic hysteresis. Hence, the lagging of B behind H is called hysteresis.